In this video, we're going to continue with confidence intervals. Now, this is going to be about confidence intervals when you are not given a population standard deviation, or when that would be considered unknown. Now, look at the formula you have for the confidence interval. It's very, very similar to the previous, except instead of z, you have a t, and instead of sigma, you have s, lowercase. Remember, lowercase s represents a sample standard deviation. Now the t represents a t-score, which means you're going to be using the t-score table. Now the t-score table, instead of focusing on what's inside in the middle, it focuses on the tails of the picture, which you see here. So you notice it has that alpha over 2, so it's focusing on 2 tails, but it works also for 1 tail, and I'll explain that soon enough. So say you had a percentage of 80%. I said here's 80%. I want the t-score. Well, where you look as far as columns go, if you have 80%, you're missing 20%. You look up what you're missing. Now the 20% that you're missing would be in both tails combined. Or if you have 80, you cut that in half, that's 40. So if you have 40 here, that means you'd have 10% in the tail, which is taking you to this column. You have 10% in one tail or 20% in 2 tails. They give you the same results. Now you use this formula or t-scores primarily when you are not told or you are not given a population standard deviation and you have fewer than 30 items. Because I know number 2 right there can seem to be a little contradictory, but that's what it's referring to. Now number 1 says the number of calories per candy bar for a random sample of standard size candy bars is given. Estimate the mean number of calories per candy bar with 98% confidence. The numbers you're given are 220, 220, 220, 210, 230, 275, 260, 240, 260, 220, 240, 240, 280, 230, 280. So in total you were given 14 items. So n equals 14. Now you have to think back to the beginning of this course. When you were given raw data values like this, you would punch those numbers into your calculator and have it spit out the sample mean and sample standard deviation, and that's what you're expected to do here as well. So you're expected to punch all of these numbers in, the 14 numbers I just told you, and have it spit out X bar, which should be about 229.1, and your sample standard deviation, which should be about 63.84. So you have everything for the formula except for your t-score. So we'll start to determine that. Now, again, to figure out t-scores, you don't use what you're given or told, but you use the leftover. So if you're told 98%, that means there's 2% left over. Now that 2%, or 0.02 as a decimal, is for 2 tails. If you take 2% divided, or cut it in half, you get 1%, or 0.01, and that would be for 1 tail. Now you're going to take either of those, and you're going to have to crosshair that with this thing called degrees of freedom. Degrees of freedom is always 1 fewer than the number you were given. So the number of things you're given is 14, so degrees of freedom would be 13. So I'm going to need to crosshair 13 and 2% 2 tails. So go to 13. Here it is. And I need to look for 2% in 2 tails, or 1%, 0.01 for 1 tail, which would be the second column. So it looks like your t-score is going to be 2.650. Now notice, t-scores are 3 decimals, not 2 decimals. So whenever you're working with t-scores, you should use 3 decimals, but for this case, I'm okay if you drop off the 0 on the end. That's no biggie. But recognize and realize, because further in the future you're going to deal with t-scores again, t-scores are 3 decimals. So 2.65. So t sub alpha over 2 would equal 2.65. Now, write down the formula, plug in the formula. So x bar minus your t-score times the quantity of standard deviation divided by square root n, smaller than mu, and that's smaller than the same thing on the left, except it's a plus instead of a minus. So plug in. So I have 229.1 minus 2.65 times the quantity of 63.84 divided by square root of 14. Yeah, it's 14. The only time you use one fewer is the table, never any other time. And it's less than mu, which would be less than the same thing, but a plus, as on the left, but a plus. And then punch in one side all at once, so that way you can go back and change your minus to a plus or your plus to a minus. Does not matter which way you go. When I plug in everything that's on the left side, I end up with 183.89. Change my minus to a plus, and that gives me 274.31. Now this wanted me to estimate the mean number of calories. Well, the rule for mean is go one more decimal than what you were given, so the left side number would round to a 0.9, and the right side number, I can just drop off the 1, because that would round down. And then I'll go ahead and put calories, or CAL, as a label for both those. So this number 2 says, a random sample of 15 registered nurses in a large hospital showed that they worked on average 44.2 hours per week. The standard deviation of the sample was 2.6. Estimate the mean of the population with 90% confidence. So I'll write down what I'm given. It says a random sample of 15, so that means n equals 15. And usually if n is less than 30, it's a t-score. So what I want to look for here, or think back, was I told population standard deviation. No. So it is in fact t-scores. Now it said this sample worked on average, which means x bar, is 44.2. They gave sample standard deviation is 2.6, and they want 90% confidence. Now for t-scores, you don't use what you're given, but you use the remainder of what's left over. So if they want 90%, that means 10% is left over. And that 10% would be for 2 tails, or 0.10. Half of that is for 1 tail, which would be 5, or 0.05. And I'll have to crosshair that with degrees of freedom. Degrees of freedom is 1 fewer than what you were given, which would be 14. Now be careful, because I know 10% pops up twice on the t-score table. Make sure you're focusing on 10% two tails. So 10% one tail or 10% two tails. Notice they're back to back. Careful there. But we want 10% two tails or 0.05 for one tail, which is going to give us, and the degrees of freedom for this was 14. So drop down to 14. In this column, you get 1.761. So the t sub alpha over 2 is 1.761. Now let's write down the formula. And then after that, write down the values plugged in. So x bar is 44.2. Your t-score is 1.761. Sample standard deviation is 2.6. N is 15. And you have the same thing on the right side, except instead of a minus, you have a plus. Punch in one of these sides, it does not matter which. I'll start with the left side, and when I punched in the left side, I got 43.02. Went through and changed the minus to a plus for the right side, and that gave me 45.38. Now it wanted me to estimate the mean, but it was wanting to estimate the mean of hours per week. So this would represent, so you'd have about 43 hours to 45 hours. So you go one more decimal than what you were given. So first decimal, so essentially 43 hours compared to 45.4 hours. Now number 3, I see a whole bunch of data values, which means you're going to need to go through and punch in all those numbers to your calculator to figure out x bar and sample standard deviation. This says the approximate cost for a 30-second randomly selected spot for a video in a random selection of sites is shown. Estimate the true population mean cost for a 30-second advertisement on a site with 90% confidence. Your data values are 14, 55, 165, 9, 15, 66, 23, 30, 150, 22, 12, 13, 54, 73, 55, 41, 78. You should have counted 17 numbers. So n equals 17. Punch those in. Your x bar should be giving you about 51.47. Sample standard deviation of this is pretty high. It's 45.98, and it's probably high because you have the 150 and 165, and then you also have 9, 12, 13. So you have real big differences between your numbers going on here. Now they're looking for 90%. That means how much is left over? You have 10% left over for two tails. Which would be the same as 5% one tail. So 0.10 or 0.05. Degrees of freedom was one fewer than what you were given, which means 16. So we're going to look at 16 and 10% two tail. So 10% two tail, again, be careful. So 10% two-tail and degrees of freedom of 16 gives you 1.746. Now write down the formula. And then plug in your numbers. So 51.47, 45.98, oh, sorry. Nope. 51.47 minus my t-score, which is 1.746. So 51.47 minus 1.746 times the quantity of 45.98 divided by square root 17. And then you have the same thing on the right side, except it's a plus instead of a minus. So plus 1.746. And still times 45.98 divided by square root 17. Punch in one side, does not matter which side. Start with the left, and it just gives you, it rounds to 32. Because if you try and go 2 decimal place, you're still going to have to round and carry up, because I think it's like 31.99 something. The right side gives you 70.94. Go one more decimal than what you were given, so this would be from 32 to 70.9. And this was talking about what? It's talking about the approximate costs. So, actually, this should be 0.94. I'll just need to go through and put a dollar sign for these. So it'll be from $32 to $70.94. This fourth one says, a large company found that the average work time lost by employees due to accidents was 98 hours per year. They used a random sample of 18 employees. So already I know, okay, n equals 18. The standard deviation of the sample was 5.6 hours, so S equals 5.6. Estimate the population mean for the number of hours lost due to accidents for the company using 95% confidence interval. X bar was mentioned at the beginning, that was 98. Now they're giving or wanting 95%, so what I'm going to use is the leftover, which would be 5% for two tails. Half that is 2.5%, which would be one tail. 5% as a decimal is 0.05. 2.5% as a decimal is 0.025. I'll crosshair either of those with degrees of freedom being 17. So 17 and 5% two-tail. So 5% two-tail, and be careful. You look at this last one, that's not 5%, that's actually 50%. So 5% two-tail is the first, second, third column. And my N was 18, so degrees of freedom 17. So go to 17, crosshair with the column for 0.025 one tail or 0.05 two tail, and you get 2.110 or 2.11 I'm okay with. So 2.11. Now write down the formula. So X bar minus T-score times sample standard deviation divided by square root n is smaller than your mu, which is less than x bar plus t-score times sample standard deviation divided by square root n. Now plug in the numbers. So you should have 98 minus 2.11 times the quantity of 5.6 divided by square root of n, which was 18, less than, match what I just wrote, except put a plus. So 98 plus 2.11 times 5.6 divided by square root 18. Punch in one of these two sides, does not matter which, but I got 95.21 and 100.79. Now what this represented is it was number of hours lost. So I need one more decimal than what I was given, which means 95.2 hours to 100.8 hours. A little different with the t-score. I'm expecting that to throw some of you off, which is fine. Just go ahead and ask me about it.